Hello guys and welcome back. We are going to do longest common subsequence problem today, and this is a pretty cool one because I don't think the solution is that straightforward unless you know exactly how to solve it and you know the concept behind it. But don't worry, we're going to discuss that today, and I would like for you to first understand and read the problem, come up with some solutions of your own, do some brainstorming, and then we can finally come to the actual solution. Okay, so without any further ado, let's read the question. You have your text 1, text 2 kind of given over here, and you have to return the length of the longest common subsequence between these. So you have ABCDE, you have ACE, and the longest common subsequence is ACE, as you can see. So you have to kind of ignore B and D, and yeah, that's what subsequence is, I guess it is. Okay, so length of LCS is equal to 3, which is length of ACE. So that's the problem. Okay, now let's dive into the solution. Okay, so the solution is pretty wild, honestly, because here we are going to talk about DP. Okay, and all of this might look like a lot of gibberish at first. So DP is basically dynamic programming. Okay, we're going to have this kind of a table sort of thing where we keep maintaining and updating these values, okay, very smartly, and we come up with our final solution. All right, so let's go step by step. You have your text 1, you have your text 2, and this is what you wanted to return. Let's not think about that right now. So for your text 1, you have your length 1, which is going to be 5, and length 2, which is going to be 3. So in this case, I'm just going to sort of discuss this solution because that's how we're going to kind of get it and have that moment where you're like, yes, I get it now. Okay, so this is what you've done, length 1, length 2, kind of, okay, and you have your DP, okay, you have your DP matrix, okay. So this is your entire big gigantic matrix which has length plus 1 and length 2 plus 1. So these are the dimensions. So since it was 5 and 3, we get a 6 by 4 matrix, okay. And these are going to be all your I values, these are going to be all your j, and you're going to kind of run 2 for loops, and we're going to go through all these values. Okay, so like this, okay, perfect, cool. Now what we do is basically translating this code for this is basically this part. Okay, forget the oo part. This part, if letters for I and j, that is I comma j, for a particular cell, if they match, then you do diagonal plus 1, else you do this max of this and this. Okay, up and down. Oh, did I say up and down? I don't think I meant up and down. Wait, wow, we didn't mean up and down, we meant left, up and left, right? Yes, up and left. Okay, awesome. So since A and A match, that's gonna make it 1. So we're gonna take this here. Oh my god, our skills are clearly getting a little rusty. 1. Okay, so that's your diagonal plus 1. Then you move to the next one down here. Okay, so you compare C and A, they do not match, so you take the max of up and left, so that's gonna be 1. Okay, so this might not make sense right now, but it's kind of going to click after a while. Okay, so let's just trust this process and keep doing it. Okay, so here also you have A and E, and again you're going to do the same thing, that is copy and paste this, right? So as you can see that up till now, if our strings were text 1 is equal to A and text 2 is equal to ACE, our answer would have been 1, which is right, which is the length of the longest common subsequence. So that makes sense, we're sort of maintaining a huge table, but what we want is the end over here maybe, where we get all the values. Okay, so let's quickly do that. So you have your B, you have your A, and you're gonna basically copy and paste. B and C, again another copy paste, because you're just basically keeping the same value, because as you can see, finally we will do this, because AB string and ACE string still have 1. So you're gonna get how it's kind of clicking, right? AC is again 1. Wow, I like it. Now where you have C and C matching, you do diagonal plus 1, right? So you're gonna get 2 over here. Amazing. And you could add your little diagonal arrow over here. Okay, so we've taken this. So that clearly means that ABC and ACE will have whatever this matrix or this cell contains, and that is going to be 2. So it's going to contain 2, right? Awesome. So I think this is somewhere where it should click that, oh, we are maintaining max length in these cells, and we keep the max one, and like we keep the max one always while updating, or else if it's the same, then we add 1. So it's pretty simple, right? That's all that, you know what we're doing, all that what we're doing. Wow, all that we're talking about here. Okay, so as you can see, this is our solution. Now I think it will be less intimidating. I don't think it should be that intimidating with these for loops, but I never got these. Okay, but I think they make sense now. If text1 dot car at I minus 1. So we've kind of maintained this little as a void 0 ka thing, because why not, right? No, not why not, because we need an origin somewhere to start with. Okay, and originally everything we're just assuming is 0. Fair. And we start from this and we start deriving. So if these characters do match, then we do diagonal plus 1. So diagonal is going to be I minus 1, j minus 1. Else we're just going to do I minus 1 comma j and I comma j minus 1. Okay, we're going to take the max of both of them. Okay, and that's how we're going to go about it. Finally, we're going to return the last cell. Okay, so that's your longest common subsequence problem. I hope you understood, and let's actually move to the code so that we do a quick revision of how this works. Okay, so I hope you've understood, and please do try to code it on your own. The solution's literally here, but let's try to code it together. Int L1, as we had named it. What is this? This is equal to text1 dot length. Awesome. Then your int L2 is equal to text2 dot length. Also, I'm not going to see the solution. I'm going to try to code it all on my own, and if I'm making any mistakes, then we will find out after we run the problem. Fair. So we first took our L1 and L2 and we made our big DP matrix. Okay, how does that go? New int L1 plus 1 and L2 plus 1. Wow, I've really not coded in such a long time, but it's kind of fun to be back. Is it? Yeah. Okay, so for int I is equal to not 0, we're starting from 1 because we want those zeros to be empty as in 0. Yes, nice. I is less than equal to L1, because again our thing is L1 plus 1. So kind of the whole commotion about this plus 1 is basically maintaining that void 0 bracket or whatever. Right, I plus 1 plus. Then again for int j is equal to 1, j is less than L2, again less than equal to L2, I plus plus. We should maybe think about solving this just by L1 comma L2 and not the 0. Maybe we could do that. Maybe. But there would be some extra steps maybe in the coding. Yeah. Okay. Like the first step would have to be like some special thing. Yeah. So this is anyways better. Okay. Now we're inside our for loop. Okay. We're actually traversing this whole matrix. What do? We just have two conditions. If text1 dot car at I minus 1, if text1 dot car at I minus 1 is equal to text2 dot car at j minus 1, then we are going to say that dp I comma j is equal to dp I minus 1 comma j minus 1 plus 1. Awesome. Else, what are we going to do? We're going to say that dp I comma j, I comma j is equal to math.max. Wait, is it max? Wow, Gargi. dp I minus 1 comma j comma dp I comma j minus 1. Perfect, parfait. And finally we're going to return dp L1 comma dp L2. Okay, pretty sweet. Let's see if we have any errors in our code. But as you can see, coding this isn't the hard part, honestly. You just need to remember what you're doing. Okay, where did we go wrong? Oh, that's the problem. We oh my god, our I must be so much because we didn't. Oh my god, yes, that's a silly typo. Right, so that's clear over here. Yeah, wow, that was dumb. Oh, all those comments I should remove. So yeah, that's our solution. That's the standard DP solution, okay, that you should be talking about. Let's see how much that beats. I think there's a better solution where you don't use DP, where you like, which is very weird, honestly. I really need to learn it. Wow, we have Chinese. Yeah, wow, we're literally talking about ASCII values here, some bit manipulation. That's something. Okay, but yeah, I hope you understood this super simple sort of problem, and we're going to practice a lot of more such problems so that we actually start coming up with these solutions on our own, where we understand, yeah, let's make a table, let's do something with these values, and that's basically what DP is for you. Okay, I think coin change is something that we've done in class, where we do a pretty similar thing. Okay, like those 1, 3, 5, 7, 10 and so on. Okay, so yeah, nice, that was our solution. I hope you liked it. Thank you. Bye bye.